In this video, we are going to talk about balancing of redox equations. First of all, what do we mean by redox? Redox actually simply means reduction and oxidation. Reduction and oxidation. So we can say that a redox reaction is a reaction in which both reduction and oxidation are occurring at the same time. The truth is that whenever you have oxidation in a reaction, it is always accompanied by reduction. So if there is a reaction where you have oxidation of a particular atom, then it must be accompanied by reduction of another atom. That is why we call it redox reaction, because both of them go together. So now we want to learn about balancing of redox reactions or redox equations. There are different methods of balancing redox reactions, but for this particular video, we are going to be learning about half reaction method. So we are going to be using half reaction method, which is one of the easiest method of balancing redox reactions. So to balance redox reactions using half reaction method, we are going to be following some steps. What is the first step? The first step is identify the medium of reaction. So you have to identify the medium in which the redox reaction is taking place, and you can have three media. You can have acidic, the medium can be basic, or it can be neutral. So for this video, we'll firstly learn about balancing redox reaction in acidic medium. Then subsequently, we'll learn how to balance in basic and neutral medium. So how do we balance redox reaction in acidic medium? So now that we've identified that we want to balance in acidic medium for this video, the next step is to balance the equation atomically. That means balance the number of atoms at the right hand side and the left hand side. So how do you do that? You start with the central atom. Firstly, balance the central atom. Then next, balance each oxygen atom. Balance each oxygen atom by H2O at the other side of the equation. What does this mean? If you have an excess oxygen atom at one side of the equation, you balance it by 1 mole. We balance each oxygen atom by 1 mole of water at the other side of the equation. Then balance each hydrogen atom by H plus at the other side of the equation. So which means that if you have an excess hydrogen atom at one side, you balance it by H plus at the other side. Hope you're following. So after you balance the equation atomically, then step 3 is to balance the equation electrically. So what do you mean by that? You make sure that the total number of charges are equal for both left hand side and right hand side of the equation. So you balance the equation electrically. Now we are going to pick an example to explain what the steps we just listed. So let's look at this example. Balance the redox reaction below in acidic medium. Iron 2 plus tetraoxomanganese 7 iron gives iron 3 plus plus manganese 2 plus. So we are using the half equation method. Like I said earlier, we are using the half equation method. So using the half equation method, we are going to split this reaction into two half equations, which is the oxidation and reduction. If we look at the equation, iron 2 plus goes to iron 3 plus. That is oxidation, because remember that oxidation is an increase in oxidation number. So from plus 2 to plus 3, this reaction is oxidation. So we can split this into the half equation. Fe2 plus goes to Fe3 plus and call this oxidation. While here, manganese goes from plus 7 to plus 2. If you calculate the oxidation number of manganese here is 7, tetraoxomanganate 7. So it goes from plus 7 to plus 2. That is a reduction, because reduction is a lowering of oxidation number. So the second half equation will be MnO4 minus gives Mn2 plus, reduction. So we are going to resolve each half equation. We are going to balance each half equation and then combine both of them as a net ionic equation. So let's do that. Balance the equation atomically. Remember, from the steps, we said we are going to balance the equation atomically. And when we are balancing atomically, we balance the central atom first. We're going to balance the central atom. So for the first one, Fe2 plus gives Fe3 plus. Atomically, this equation is already balanced. We have 1 mole of iron here and 1 mole of iron here. It is balanced atomically. So let's look at the second equation. MnO4 minus gives Mn2 plus. Manganese is balanced. We have 1 atom here, 1 atom here, but oxygen is not balanced. We have 4 atoms of oxygen here. We have no oxygen at the other side. So let's go back to the steps. It says that balance each oxygen atom by H2O at the other side. So how many oxygen atoms do we have here? We have 4 oxygen atoms. So to balance it, we are going to add 4 moles of H2O at the other side. 4 moles of H2O, because it says balance each oxygen atom by H2O. So we have 4 oxygen atoms, we add 4 H2O to the other side. Now there is a problem because we've introduced hydrogen to the equation. So how do we balance hydrogen at this side? Let's go to the steps. The step says that balance each hydrogen atom by H plus at the other side of the equation. So we balance, how many hydrogen atoms do we have now? We have 4 moles of hydrogen, which is 4 times 2. That's a total of 8 atoms of hydrogen. So which means we are adding H hydrogen ion to the other side. So it will become MnO4 minus plus 8H plus gives Mn2 plus plus 4H2O. So now the two equations are balanced atomically. So we can move to the next step, which says that balance the equations electrically. So now we want to balance the charges. The first equation is Fe2 plus goes to Fe3 plus. It's obvious that the charges are not balanced. We have plus 2 here, we have plus 3 here. So how do we balance the charges? We balance the charges by adding electrons. And remember that electrons are negatively charged. So if we have a total of plus 2 here and a total of plus 3 here, where can we add electron to make the two charges balanced? Can you guess? Can you take a guess? Yeah, sure, the right hand side. And how many electrons are we going to add? We are going to add 1 electron, such that 3 plus 3 minus 1 will give us plus 2. Remember that electrons are negatively charged, so one mole of electron is minus 1 plus 3, that will be plus 2. So which means that to this side we are going to add 1 electron plus E minus. So let's look at the second equation. What do we do to the second equation? The second equation, MnO4 minus plus 8H plus gives Mn2 plus 4H2O. So let's see if it's balanced ionically or not. Here we have minus 1. The charge here is minus 1. Here we are going to do 8 multiplied by plus 1, that's plus 8. So at the right hand side, at the left hand side, we have a total of plus 7 charge. Minus 1 plus 8, that's plus 7. Here we have plus 2. And the charge here is 0. We have no charge on H2O water. So which means that at this side, we have a total of plus 7 charge at the left hand side, while at the right hand side, we have a total of plus 2 charge. So how many electrons do you think we are going to add to this left hand side to make it plus 2, to reduce it to plus 2? Yeah, we're going to add 5 electrons, because remember that electrons are negatively charged. So 7 minus 5 will give us 2, which means that we are adding 5 electrons to the left hand side. So the equation will now become MnO4 minus plus HH plus 5 electrons gives Mn2 plus 4H2O. All right. So now the two equations are balanced atomically and electrically. So let's write the two equations again. So we have Fe2 plus gives Fe3 plus E minus. So we also have MnO4 minus plus 8H plus 5E minus gives Mn2 plus 4H2O. Now we are going to do something. We want to make sure that the number of electrons for both oxidation and reduction reaction are equal. So here we have 5 electrons, here we have 1 electron. So we are going to multiply equation 1 by 5 and multiply equation 2 by 1, so that the number of electrons are the same at both equation 1 and equation 2. I think you get that. Multiply equation 1 by 5 and equation 2 by what? By 1. The number of electron here, 1 electron. But we don't just show the 1. We don't need to show the 1. Just writing he tells us that it is 1 electron. So let's do that. So our equation 1 becomes 5 Fe2 plus gives 5 Fe3 plus 5 E minus. And equation 2, because we are multiplying equation 2 by 1, it will remain the same. MnO4 minus plus 8H plus 5 E minus gives Mn2 plus 4H2O. Now we can combine equation 1 and equation 2. Add equation 1 and 2. So if we add equation 1 and 2, we get our net ionic equation. Let's do that. So this is how you are going to add. You add all the terms at the left hand side together, then also add all the terms at the right hand side together. So let's do the left hand side first. So for the left hand side, we have 5 Fe2 plus MnO4 minus plus 8H plus 5E minus gives, and for the right hand side we have 5Fe3 plus Mn2 plus 4H2O plus 5E minus. By convention, we make sure we write the electrons last. Put them last. Why? Because we still cancel them out. We have 5 electrons here, we have 5 electrons here. So what do you think? We can cancel them out. 5 electrons cancel 5 electrons. So which means that the net ionic equation will now give us 5Fe2 plus MnO4 minus plus 8H plus gives 5Fe3 plus Mn2 plus 4H2O. So this is the balanced net ionic equation. Don't forget to like, share, subscribe, and follow for more. Thank you.